EDX Core Pure, Matrices 2, Transformations and Invariants, Stretches and Enlargements in 2 dimensions. What transformation does this matrix represent? 2, 0, 0, 1. We're going to apply that matrix to that object. So we're going to represent the 3 vertices with the column 0, 0, 2, 0, 2, 1. When I do the multiplication, so multiplying the top row of the first matrix by each of the columns of the second matrix. So the first multiplication will give me 0, the next one 4, and the next one 4. Then multiplying 0, 1 by each of the columns of the second matrix will give me 0, 0, 1. And if I plot those 3 points to create the image, we can see that the transformation is a stretch parallel to the x-axis by a scale factor of 2. And that's what that element 2 has produced. What transformation does this produce? 1, 0, 0, 3. There's the object we're applying it to. And here goes with the multiplication. So multiplying the top row by each of the 3 columns will give me 0, 2, 2. The bottom row 0, 3 by each of the columns will give me 0, 0, 3. And if I plot those 3 points to create the image, there's my image, and the matrix represents a stretch parallel to the y-axis by a scale factor of 3, and that's what that element 3 has produced. What about the following matrix? 2, 0, 0, 2 multiplying by that object. So I'm going to do the multiplication to create the image. So the top row multiplied by each of the 3 columns will give me 0, 4, 4. And the bottom row multiplied by each of the 3 columns will give me 0, 0, 2. So the image looks like that. And the matrix represents a transformation which is an enlargement by scale factor 2. So that's what those 2 elements have produced. They've enlarged the entire object by a scale factor of 2. So in summary, K001 is a stretch parallel to the x-axis by a scale factor k. 100k is a stretch by scale factor k parallel to the y-axis. H00k is a stretch horizontally by h and at the same time vertically by k. And K00k is an enlargement by scale factor k. So example, we've been given a matrix T, which is 1 root 3 minus 1, and we want to find T squared, and then describe the transformation it represents. So T squared is 1 root 3 minus 1. Remember, I wouldn't recommend squaring the matrices by inspection. I would write it out. Far less likely to make a mistake. So, looking for the top left element, we're going to multiply 1 root 3 by 1 root 3, which is 1 plus 3 is 4. To get the top right element, we're going to multiply the 1 root 3 by the root 3 minus 1, which gives me root 3 minus root 3, which is 0. To get the bottom left element, we're multiplying the bottom row, which is root 3 minus 1, by the first column, 1 root 3. So that's root 3 minus root 3, which is 0. And to get the last element, we're going to multiply the root 3 minus 1 by the root 3 minus 1 to get 3 minus minus 1, which is 4. I can tell by looking at that answer, describe it fully, this is an enlargement. So it's been stretched in both directions by the same scale factor, so it's an enlargement with a scale factor 4. Again, you can investigate these transformations using the GeoGebra file given and see what happens to the points 1, 0 and 0, 1 under various transformations. In the next session, we're going to be looking at successive transformations in 2 dimensions.